Ladies and gentlemen, boys and girls, children of all ages, we're going to start today's class. Actually, I already started it by talking a whole lot and boring the new kids, but that's okay. We're going to start the instruction in today's class by multiplying 3-digit by 1-digit factors. 1-digit factors times 3-digit factors. The numbers that are multiplied together are called factors. The answer is called the product. So if you ever get it says, find the product, then that's the answer to a multiplication problem. I know you may not have them all written down. That's fine. We're good. We're good. Our first one we had to do was 116 times 3. I'm going to write it. All right, when you do a problem like this, I would always write it vertically. It's easier. And I'd always put the factor with the most digits on top, because it's easier. Now what I found in my 73 years of teaching is that students freak out on multiplication and division. I've seen it happen. Right now some of you are trying to pretend like you're not going to freak out, but you're going to. And that's fine. But you can use your multiplication chart. Well, that doesn't help me when I'm doing 27 times 306. Yes, it does. Because you're only multiplying one digit at a time. So if you know your zeros through nines, or you can read your multiplication chart 0 through 9, and then you can do some adding, which is one-digit numbers, then it doesn't matter how many digits are in your factors. It's all the same. Alex, you had a question?
I split up my numbers and then added them once I multiplied them.
Okay, that'll work too. All right, so I'm going to show the standard algorithm. We'll show different ways, the way kind of like Alex did, and that's fine. And so you'll have different options of how to do it, and that's fine. But if you can learn how to multiply, division is easy. It doesn't matter if it's 2-digit divisor, 2 digits outside. Division's easy if you know how to multiply. So if you stick with me, division's going to be easy for you. All right, again, I said it's only one digit at a time. So 3 times 6 is, anyone? 18. So that's 3 times 6. 3 ones times 6 ones is 18 ones, which I can't write 18 ones, 18 in the ones place. So I put 8 ones and make 1 10. See, that's the difference from when I was in school. They just say, and put the 1 up there. I don't know why. Just put it up there. Well, now you know why. So now I have 3 ones times 1, 10, which is
3 and plus the 1 is 1.
and plus the other 10 that I had, so then I have 4 10s. And I have nothing. 4 10s I can keep. I don't need to change 10 of those to 100 because I don't have 10 of them. And then I have 3 times 1, which is 3.
Yes.
Now what is the inverse operation of division? I mean of multiplication. I just gave you the answer. Division! Gosh, you guys are smart. If I wanted to check my work because I care about my grades, or I got it wrong the first time, and then I thought, why did I get this wrong? So I'm going to do it a second time. Then I could always divide my product by my factor. I'm just teaching you, Maddox. Teasing you, Maddox. And so that's a way to check it. And we can obviously do that. I'm not going to work that out for the sake of time here. The second one we had was 338 times 4. (338 times 4). Now, all I have to know to do this problem is my multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 36. That's all I have to know. I need to know those multiples of 4. And I can do this problem. I could do it, and this is not the problem, so don't write it down. But if I knew my multiples of 4, and my multiples of 6, and my multiples of 7, all I would have to do is use those. It doesn't matter that I have all these here. Now, they're not in this particular problem, but all I need to do is know my multiples of 4. So, 4 times 8 is? 32. 4 times 3 is?
12.
Plus 3 is? 15. 4 times 3 is?
12.
Plus 1 is?
13.
So 1,352. Again, I could, if I wanted, take my product and divide it by my factor. It's easier the smaller factor, because I wouldn't want to do 1,352 divided by 338. That'd be a pain. I mean, I could do it. It just would require more time and more work, so I'm going to take the easiest possible route if I was doing that. Let's look at the third one that we had. 219 times 6. Again, if I know 6, 12, 18, 24, 30, 36, 42, no, that's not 42. Yeah, 42, 48, 54. Then, if I know my 6's, then it doesn't matter how many digits I have here. So, if I didn't know my 6's, I'd always look at my multiplication chart. So 6 times 9 is?
54.
54. So I have 54 ones. Well, nobody wants to walk around with 54 ones. So we keep 4 of the ones, and we change those other for 5 tens. Because then your wallet's not nearly that fat. So now I have 6 ones times 1 10 is? 6. Plus 5 more tens? 11. 11 tens. Well, I don't want 11 $10 bills when I can have one $10 bill and one $100 bill. 6 times 2 is?
12.
12 plus 1 is?
13.
13. 1,314. 1314, yes. It looks like the majority of you seem to be yesing and getting them right. So that looks good. I think we have enough time for the last one.
Yeah.
Let's look at 456 times 7. $456 times 7. Again, if I know 7, 14, 21, 28, 35, 42, 49, 56, 63. If I know those, you're supposed to tell me when I forget.
I did.
Okay. If I know those, this problem's easy. If I don't know those, I look at my multiplication chart, and this problem's easy. What you got to get in your head is multiplication is easy, because it is. So don't start thinking, I can't multiply, it's too hard. No, it's easy. 7 times 6?
42.
42. That's 42 ones. I don't want to carry around 42 ones, so I keep 2 of them. I trade 4 of them in for 10s. So now I have 4 more 10s than what I had over here. 7 times 5?
35.
35. Plus my 4 10s that I had?
39.
39. 7 times 4?
28.
28. Plus 3 more hundreds?
31.
31.
3192.
3,192. Okay? How many of you feel okay about this? Okay? Good. I'm glad you feel okay about it. Kind of. That's fine. That's fine. Kind of. Good. Good. All right. All right. We're good. Boom! Shakalaka. Peace out. God bless. Love you. Do something kind today. Subscribe to Keller GBB.
Keller GBB.